The universe.
How can something so immense, so precise, so delicately ordered exist at all? What set its laws into motion? What chose its constants, its balance, its time? Is the universe a product of blind chance, emerging from nothing without purpose, or does its harmony point to a hidden intelligence, a will, a power beyond the material? This is the question that echoes through science, philosophy, and faith. And it is here, in this tension between knowledge and wonder, that our exploration begins. When we look into the cosmos, we see a deep, endless darkness stretching in all directions, glowing with scattered points of light stars, planets, and galaxies. Some of these celestial bodies are so distant that their light travels billions of years before reaching Earth. For centuries, humanity has tried to measure and map the universe. Yet every instrument falls short. Telescopes reveal astonishing distances, but never the whole. Sensors detect particles, but not the ultimate foundation. The universe remains mysterious, vast, overwhelming, and beyond full comprehension. And then, at the opposite extreme, there is the atom, the smallest building block of matter, a tiny nucleus of protons and neutrons wrapped in a cloud of electrons. Something so small, it cannot be seen with the naked eye. To put it in perspective, an atom is about 100,000 times smaller than a human hair. Yet, it forms the very foundation of everything we know: stars, stones, the air we breathe, and life itself. It is the beginning of all matter. Can such precision and complexity, both infinitely large and infinitely small, truly have emerged by itself? Or does it hint at something beyond nature? A power, a will, an intelligence? As some call God? Can this universe have brought itself into existence? In 1927, a Belgian priest and physicist, Georges Lemaître, introduced the idea of the primeval atom, a single dense origin from which the universe expanded. This theory became the foundation of the Big Bang. Soon after, Edwin Hubble confirmed that galaxies are moving away from each other. The universe is expanding.
We know that the universe is expanding. We've known that for almost 100 years. The rate at which the universe expands is a number we refer to as the Hubble constant. When Hubble was launched, one of its main objectives was to measure the Hubble constant, the expansion rate of the universe, by resolving individual stars in distant galaxies. Hubble was really the first telescope that allowed us to easily resolve the individual components, the stars, in a distant galaxy to gauge its distance. And that's part of the ingredients you need to measure the expansion rate of the universe. Over time, Hubble also was improved by a series of servicing missions that increased the sensitivity, resolution, and also ultimately allowed us to make observations in the near infrared, which reduces the effects of dust. Dust is scattered throughout the universe, and if you're looking at a distant light and trying to tell how far away it is, dust can dim the light and fool you into thinking it's further away than it is. Hubble has sort of all of these tools on its utility belt that allow us to measure the expansion rate as well as it's been measured to date. Hubble found that the expansion rate of the universe is speeding up, it's accelerating due to a new component of the universe that we call dark energy.
This raises a profound question. Did such an explosion of order, laws, constants, and harmony emerge out of absolute nothingness? Or is the very beginning of the universe itself a sign of intention? Remarkably, the Quran, written over 1400 years ago, contains verses mirroring these scientific discoveries. And it states, "The heavens and the earth were one, Then we separated them. And we are indeed expanding the heaven. Coincidence? Or revelation? Again, the question arises. Could this universe have brought itself forth? Or does this knowledge reflect guidance from a higher intelligence? And it doesn't stop there. High above the Earth, between 1,000 and 25,000 kilometers, lie the Van Allen radiation belts, protective layers of charged particles held by Earth's magnetic field. They shield life from deadly cosmic radiation. The Quran describes this as well. And we made the sky a protected canopy.
During the course of geomagnetic activity, disturbances caused by flares on the sun, by big blobs of plasma coming out from the sun towards the Earth, the Earth's magnetic field is battered and shaken. Some of that energy is captured in the Earth's magnetic field, and through a variety of processes, that energy energizes particles in the Earth's radiation belts up to energies that are hazardous to spacecraft and astronauts. The Radiation Belt Storm Probes mission is NASA's mission to study the Earth's Van Allen radiation belts, two invisible regions of highly charged particles in space that surround the Earth. Each of the two RBSP spacecraft carries 5 instrument suites and a total of 8 instruments. The two spacecraft are identical. The region of space that we're talking about, where the Radiation Belt Storm Probe spacecraft will go, is one that's occupied by communication spacecraft, by weather spacecraft, by all sorts of spacecraft that you use on a daily basis. There are 2 Van Allen radiation belts. The one closer to Earth, about 1,000 miles up above the Earth's equator, contains highly charged protons that are trapped there for years and years. The further out radiation belt, the outer radiation belt, at about 1/12 of the distance to the Moon, contains a mixture of energetic electrons and energetic ions. Both of them are hazardous, but hazardous in different ways and at different times. They're always changing, waxing and waning, increasing and decreasing in strength. We don't understand why. The goals of the Radiation Belt Storm Probes mission are to determine where the charged particles in the Earth's radiation belts come from, how they get energized, and how they're lost into space. The first use for the data from the mission will be by scientists who attempt to understand the physical processes that are occurring in the radiation belts. They'll use those data to develop models for space weather in the Earth's environment, the hazardous features that surround us. However, the data can also be used by engineers to better design spacecraft. For example, if you know how much radiation is out there, you know how thick to shield your spacecraft with walls of metal. The Earth's radiation belts pose a hazard to astronauts. A hazard because prolonged exposure to radiation can cause cancer. What we want to do is understand just how much radiation is out there and just where it is, and we can warn astronauts when to be inside and outside their spacecraft. The RBSP spacecraft are focused on the dynamic radiation belts in the Earth's inner magnetosphere. They're the only spacecraft that focus on those. Consequently, they're a critical component in the series of phenomena that link the Sun to the Earth.
Could such precise protection arise unintentionally? Or does it reveal foresight, a design that allows life to exist? Can such structure truly emerge out of randomness? Our universe contains roughly 100 billion galaxies, each containing 100 to 400 billion stars. That number alone, 100 sextillion stars, a single digit followed by 23 zeros, stretches the limits of human comprehension. Yet these stars and galaxies glide through space with astonishing order. Galaxies rotate, planets orbit their stars, and cosmic structures form without colliding into destruction. This cosmic choreography raises a profound question. Can such order arise on its own? Or does it point to intention, perhaps, even to a conscious design?